Hey, a lot of ground to cover today. We're talking about angle measures, specifically standard position, coterminal angles, reference angles, some trig, and radians. Feels like a lot, but it's actually going to go pretty quickly because things are all really related. Standard position is the first thing we'll talk about. Any angle measured from the positive side of the x-axis is in what's called standard position. So this looks like it's, 24 degrees or so. Because its base was right here on the x-axis, it's in standard position. Any angle that we measure in standard position is coming off the x-axis. So this angle here, we would call it goes 90, 180, about 190, 195, I don't know. We'd say it's about 195 degrees. And this angle here, from on the x-axis, we could do two ways. One is we could say it's about negative 30. Or we could say it's 90, 180, 270, 310. 330. It's either negative 30 or positive 330. The point is to have a standard position angle, it's always coming off the positive side of the x-axis. One of its legs is always right here. And then everything else we measure off of that, either in the positive direction, and the positive direction is going counterclockwise, or the negative direction, which is going clockwise. And that seems kind of backwards, but it makes sense if you think about where things are positive. In the first quadrant, in this quadrant here, everything is positive, then they move negative as you go this way. Next, we'll talk about coterminal angles. They're angles that end up on top of each other. So for example, if this is 30 degrees, a coterminal angle could also be going around once and then going 30 degrees at 390. Those two angles end up on top of each other, so 30 degrees and 390 degrees are coterminal. And if we say that this is 190 degrees, a couple of coterminal angles could be negative, what's that going to be? If this little guy here was 10 degrees, then this is going to be 170. Negative 170 degrees is coterminal. And I could go all the way around once and then go 170. So negative 530 degrees is also going to be coterminal with those. So when you say coterminal, it means angles that end up on top of each other when measured in standard form. It's always going to be, there's an infinite number. You can always add some number of 360 degrees. So like a 10 degree angle is coterminal with 370, which is then coterminal with 730, which is then coterminal with 1120. My math might be a little off. But you can always keep adding 360 to get coterminals because you can keep going around a circle over and over. So now that we can talk about standard position, and we can find some trig with some points. Like if I take the point 2, negative 4, and I'll say that's here, and there's some angle theta, and that angle theta is always going to be in standard position, which means it's going to be this angle here. This is the point, again, 2, 4. Well, I can find this angle theta based on what this coordinate is. When that's the point 2, 4, I know that if I draw like this little triangle here, this distance was 2 and this distance was 4. Even though it says negative 4 here, the distance traveled was actually 4. So if I think about the triangle that's made here from the x-axis, because we're in standard position, from the x-axis I want to try and find the length of this hypotenuse, the length of c. So I can do 2 squared plus 4 squared equals c squared, and that's 4 plus 16 equals c squared, and that's 20 equals c squared. Well, c is going to be the square root of 20, which I can reduce to 2 root 5. Now that I have that figured out, and I know what my theta is, I can find sine, cosine, tangent of thetas, and cosecant, secant, and cotangent of thetas. Well, sine is opposite over hypotenuse, so if this is my angle theta right here, if this is my theta, then this is the opposite. So it's going to be 4 over 2 root 5, which I can't actually have. I can't have a radical on the bottom, and I can reduce that. So I'm going to make it 2 root 5 over 5. Eventually, we'll start worrying about positive or negative. In fact, right now, I think I'll worry about positive and negative. Since this was actually in a negative position, I'm going to say this value is negative 2 root 5 over 5 because we were in the negative side of this triangle, or negative side of that quadrant. We went down from there. But like I said, we'll talk about that more a little bit later. Go thinner. Cosine is going to be adjacent over hypotenuse, so 2 over 2 root 5. The 2's cancel, it's actually just root 5 over 5. Tangent is opposite over adjacent, which is just 2. And then to find all of the cosecant, secant, cotangents, I just flip over, find the reciprocals of these ones. So this is just going to become root 5 over 2, excuse me. This will become root 5. And this will become 1/2. You can use a point to find distances of sine, cosine, tangent, and everything else based on your theta, and that point is always coming in standard position. Reference angles. Reference angles are things that give students a real problem at first because they just find them confusing even though they're not hard. I want to make this as clear as I can. A reference angle is taking any point and finding this distance here, or that angle right there between those two values. It's the distance to the x-axis, or sorry, the angle to the x-axis. So right now, this angle here, the angle inside this little curve, I can get to match this angle here. And so whatever angle this is, let's say that's about 8 degrees, then the reference angle would be 8 degrees. And whatever angle this is right here, it's always the angle to the x-axis. Let's say that's, I don't know, 60 degrees. Then we go up here, and there's your reference angle right here. It's always just an angle to the x-axis. And students get a bit confused about why that's useful, and it's very useful, but also just that it's not always going to be from this side here. It's not always from the positive x-axis, just any x-axis. So if we jump back here and I draw an xy plane, we'll say that I drew an angle that was 225 degrees. Well, I want to think just what's this piece of the angle right in here? How much is that? If all of this was 180, if that's 180, then the leftover piece is 45 degrees, so the reference angle is just 45 degrees. I'll do another one. Let's say we're doing this angle, and this angle is negative 30 degrees. And it looks like it's a little bit more than 30, but whatever. Say it's negative 30 degrees. Well, the angle to the x-axis is negative 30. You put that in quadrant 1, your reference angle is just 30. It's taking whatever your angle is to the x-axis and putting it in quadrant 1. So instead of calling it negative 30, I could have called it 330. But I could still just take this distance, this angle to the x-axis, and that's still 30 degrees. A reference angle is your angle to the x-axis. I'll do one more. I'll put one in quadrant 2. Let's say this is 121 degrees. I'll have to think, what's this angle right here? What's the angle to the x-axis? If that's 121, well, this little piece was 90, so this little piece must be 31. So this piece over here must be 59, so the reference angle would be 59 degrees. That's what this angle here is. That angle there is 59 degrees. That's reference angles. We've done a lot of talk about degrees, and sometimes I ask students, what is a degree, and they can't always tell me. So if you wanted to pause and think, what is a degree before I tell you, that might be worthwhile. A degree is actually just how we choose to break up a circle. We broke a circle into 360 parts. I said 360th, but I really should say 1 over 360 of a circle. We took a circle and broke it up into 360 little parts, and if we connect the space between 2 of those parts, and I even missed, I did 2 there, this is 2 degrees now, but a degree is the distance between, or the angle formed between 2 parts of 1 360th of a circle. It's a very, very small unit, picked because the Babylonians loved the number 60, because it can be divided by 1, 2, 3, 4, 5, and 6. But it's kind of an arbitrary way to break up a circle into just 360 pieces. A better way to break one up is into what's called radians. A radian is another way to measure degrees, or to measure angles. Degrees are one way to measure angles, and so are radians. So here I'm going to draw a radius to this circle. There's my radius r. And if I took that radius and thought of it like it was a piece of string, and I pulled it off and I tried to like string it along the circle, so like I just kind of wrap it around, about so far, there's one radius. How many times do you think it'll go around? It goes around a little more than 6 times. 1, 2, 3, 4, 5, 6, and a little bit more. And obviously it wasn't very precise. I mean, some of these are longer and shorter than the other, but it looks pretty reasonable. It's going to go around 6 times. It actually goes around 6.28 times. I mean, which is 2 pi. It goes around 2 pi times, which makes sense, because to find the circumference of a circle, you do 2 times pi times the radius. And what we're doing is we're taking the circumference and breaking it up into groups of length radius. So we're taking the circumference and dividing it by r. So c divided by r is really 2 pi. The radius can go around the circle 2 pi times. So what a radian is, remember this is a radius here. A radian is that measure of a circle. How far the radius goes around the circle, you find the angle between, and that's a radian. So like if the radius stretches about this far along the circle, connect those 2 endpoints, and that's 1 radian right there. It's another way to measure a circle, but it's way, way bigger. A degree we saw was much smaller. A radian's pretty big. It takes 2 pi radians to go around a circle, or 6.28 radians. So we have to be able to convert between radians and degrees. We know that 2 pi radians went all the way around a circle, and we know that 360 degrees went all the way around a circle. So that means that 180 degrees is the same as pi radians. And that number pi, you have to see it and think of it like it's a number, like it's 3.14159 ... But see it and don't think it like it's a variable, but that it's some number, the number pi, 3.14, that you have to work with. So let's convert a little bit. Suppose that I had, I'll do pi over 4 radians. And radians are hard at first because they almost always come in fractions, and they almost always have pi in them. And those two things make the calculations easier, and they're easy to understand, but at first they're tough to get a feel for. Pi over 4 radians is going to be how many degrees? We're going to do that conversion. Well, I take my pi over 4, I multiply it by 180 over pi. And what's nice is when you do this, the pi's cancel. Pi on top, pi on bottom cancel. 180 divided by 4 is 45. So pi over 4 radians is 45 degrees. If I wanted to do like 3 pi radians, I would do 3 pi times 180 over pi. The pi's cancel, and it's 3 times 180, which is 540. It's 540 degrees, or 1 circle and then another half, 1.5 circles. And from degrees to radians, you do basically the same thing, just other direction. 60 degrees equals how many radians? Well, I'll do 60 times pi over 180. Keep these as reduced fractions. Don't make them decimals. 60 over 180 is actually just 1 over 3. So we would say it was pi over 3 radians. And like I've said, it's weird that they're always fractions, and they always have pi in them, but you have to get used to it because it actually makes things a lot easier as we go forward. 2 important ones just to give you a feel for how this works. Oops, didn't skip that. Let's do 1 degree. 1 degree equals how many radians? Well, I take my 1 degree and I multiply it by pi over 180 degrees, and I get pi over 180, which is a very, very small number. I'll actually make that a decimal, just so we can get a feel for this. Pi divided by 180, so second pi divided by 180 is 0.017 radians. 1 degree is 0.017 radians. Whereas 1 radian, which is something you wouldn't hear very often because it usually has pi in it, to find 1 radian, I'll do the opposite. It's going to be 180 over pi. .57 degrees. So a radian is substantially bigger than a pi. A radian is substantially bigger than a degree because it covers more distance between the circle, more ways around the circle. I think that's enough for today. Thank you.